Okay, so hello everyone. So today we are going to see something about the transfer learning. So transfer learning is a paradigm in deep learning where we have gained some knowledge from some billions of data set. Mostly we are looking into the CNN part, so we will stick to the images. So it has looked into some billions of images, and we are going to use the knowledge gained over those images to do some meaningful tasks for our own data set. So what we are going to do is that we are going to use the models and fine tune it for our own purpose. Why we are doing it so? So the reason is that suppose you are trying to test something on a very small kind of classification task. So for example, you are trying to differentiate a particular species of ants. Now it might be a case that you don't have so much data available for that classification, and because there is very less amount of data, there is a high chance that your model might fail to give a reasonable result. And also there can be a issue of overtraining, like it knows, or like it is not suitable for a new kind of data set, or maybe a new data which it has not been seen in the training part. So for that, what we are going to do is that we are going to leverage the model which has been learned on some billions of data set. It shouldn't be like we are trying to differentiate only ants and all. It could have been trained on data sets which were used to classify some, say, cat species, like that. And we are going to fine tune those kind of models to do our own classification task. So if you want to know more about what is this transfer learning, so you can just go over through this link which has been mentioned here, and here you will find more detailed understanding of what is transfer learning. So the first thing is that we have to change the runtime. So for my run, I have already set it to GPU. For in normal cases, the hardware accelerated will be pre-selected to CPU. You have to switch it to the T4 GPU. So the next thing is importing libraries. We will be using the PyTorch codes for this. You can always do the same thing using TensorFlow, and I will highly encourage everyone to do the same task using TensorFlow libraries. So we will run this code. Now, what we are going to do is that we are going to use this transfer learning for a very small data set, which is uh, ants and bees data set. We are trying to classify ants and bees, and you can see that there are 120 training images each for the ants and bees, and there are 75 validation images for each class. So it's a very small kind of data set. We will use this code to extract the data in our instance, like the Polab instance. And when we run this, you can after running this, you will see this data is present over here. We will get some ants images and all this. These images you can see is all JPG format. uh, Now the second thing is that we are want to visualize this data set. So we will try to visualize this, but before that we are doing going to do some kind of transformations. So maybe we will just do some random horizontal flip. We will resize this to 224 comma 224, that so that the size remains constant across each image, like that. So let's run this code, and yep, you can see these are some of the examples. These are some random examples of the bees and ants, and you can see this is the bee, this is the bee, and these are the ants and all. Now we are going to train this model. So this is a normal training code which where the number of epochs has been set to 25, and we are going to train this on the GPU, so the device is linking to the GPU. I won't go through the code like line by line. It's highly encouraged to see this code, how does it works and all. I will just going to run this file. uh, okay, now here we are using the ResNet 18 model, and here you can see that the pretend I have kept it as false. So what it means, pretend equals to false, is that we are going to train the model on the datasets which we are already have, means we are trying to train the model from scratch. So yep, let's do this. Yeah, it's going to take some amount of time as okay. So you can see the training loss and the accuracy, it's increasing, right? Training loss, validation loss, 64%, 64.71, 72.55. It has increased, of course, no doubt, but the best validation accuracy we are getting is something like 0.771 to 177%. Now I'm taking this data sets where the images are pretty good, but you won't get like 77% accuracy in every time. It might happen that for this kind of small data sets you may even get a 30% accuracy. Now we are going to use the same model using the transfer learning part, and let's see what happens. Okay. So as you can see, it has started with 65% and 88%, and it has suddenly jumped to 90 and 92%. So you can just imagine how much there is a difference in the accuracy as compared to a model trained from scratch, as compared to a model where we are leveraging transfer learning. uh, okay, yeah, so it's just toggling between this 91 and 92%, like that, 90, 91, 92%. It has okay. So the best validation accuracy we are getting here is 94%. Here it was 77%. So you can like well imagine that how much is the accuracy difference. We can plot the same thing using this kind of plots, and you can just to visualize like how this training samples and the loss change for this kind of models for scratch and for transfer, sorry, transfer learning.